Here we have a function. Let us find its domain and range without the graph, and then we will see how the graph helps us. What sort of a function do we have here? We are dealing with the absolute function, or what we call the modulus function. What does it mean? Whatever you put inside this mod sign, whether it is positive or negative, whatever your input is, your output should always be positive. For example, if the number you have here is a positive number, then good news, it is just, the answer is just 4 itself. For all the positive x, your number, your mod value is x itself. But then what if the number you are putting in, your input is negative? You should lose this minus sign and your answer should be 4. You should just lose the negative sign. That is what it means. If your x is negative, then what do? You take minus of its value. So therefore, whatever your input is, your output should be positive. That is what the mod value means. But then here we do not have a mod x. What we have here is x minus 2. So let us rewrite the function. Now your modulus of x minus 2 is x minus 2 itself if it is positive, and it is a negative of x minus 2 if it is negative. But then our function has something more. We have to add this also and then rewrite the whole function. Then what will this look like? This will be 3 minus x. For what values of x? For all the x minus 2 greater than 0. When is the difference of two numbers positive? When the first number is greater than the second number. And similarly, what will this be? Opening the brackets, you will see this is x minus 1. And for what values of x? It is for all of these values where x minus 2 is negative. When is the difference of two numbers negative? When the first number is less than the second number. So this is what your function looks like. We have rewritten it, and now tell me what will be the domain of such a function. For what all values of x is this defined? Now look at all the numbers which are greater than 2. Here, for all the numbers greater than 2, 3, 4, 5, 1 million, 100, all of that, what is the function? It is 3 minus x. It is a polynomial of degree 1. It is a linear polynomial, which means what? When you graph it, you will get a line, which means what? For all of this, it is completely defined. Now, come to the next one for x less than or equal to 2, which is what? 1, 0, minus 2, minus 4. Again, for all of these values, you have a linear expression. You have a polynomial of degree 1, which means when you plot it, you will get a beautiful line. So again, domain is defined for all the numbers less than 2 also. Then comes the very important question. What about at the point 2? Is it defined? How do you know if it is defined at the point 2? It should have only one image. For example, if you take x is equal to 4, it will have only one image, which is minus 1. Here, if you take x is equal to 0, you will get only one image, which is minus 1. But then, if you take x is equal to 2, will you get one image? Only one image. Put 2 here. What do you get? F of 2 is equal to 1. Now put f of 2 here. What do you get? Again 1. So good news, it is defined at 2 also. If instead of x minus 1, for example, if instead of x minus 1, what you had is, say, x plus 1. Then what happens? Here you put 2, you will get a 1. But here if you put 2, what will you get? You will get a 3, which means what? 2 will be mapped to two numbers, 1 and 3. Or in other words, the single element 2 is going to have two different images. Then it will not be a function. How have we defined a function? Each element should have a unique image. It cannot have two images. Then at that point, it will stop being a function. But then here we don't have such a problem. The good news is that in both the places, if you put 2 here or you put 2 here, you get exactly the same answer. F of 2 is 1, or in other words, at 2 also it has a unique image. And what does that mean? X is defined for every real number. The good news is that your domain is the whole of the real numbers, or for all the numbers greater than 2, for all the numbers less than 2, and at the breaking point 2 also it is defined. So that's a good news. Now we go on to range. What is the range? What is the maximum or the minimum value that this function can take? What is this function? It has a mod x minus 2, which means what? It's a mod function, which means whatever you put inside it, positive or negative, does not matter. What comes out of it is a positive number. So, but then we need a minus here. If we multiply throughout with a minus 1, what happens? Your inequality flips. Your inequality changes. There are two main things that you have to remember which will flip your inequality. One is multiplying or dividing with a negative number. That is one thing which will change your inequality. Another thing is taking the reciprocal. If you take the reciprocal also, your inequality will change. Please remember that. But still, this is not our function. We need a 1 as well. Add a 1 to both sides. So what do you see? You see that the greatest value that our function can take is 1. You can never get 2. You can never get 3, 4. You cannot get 1.2. Done. Your maximum number is only 1. So what is the range? What is the range? The range has to stop at 1. It can be any less. You can get however low the value is, you can get, but maximum you can do is 1. Now let us just test that. We have got this as the range, and we are saying that this whole thing, if we take this is equal to y, we are saying that this y can never be greater than 1. Can we take an extremely small number and a big number and test our answer? Take 100 here. 100 minus 2 will be 98. So 1 minus 98 will be what? Minus of 97. Now here, then take minus 100. Then again what will you get? You will get this whole answer. You will drop the negative sign. Your answer will be 102. 1 minus 102 will be minus 101. So whatever you do, however big, however small your x is, you can never go more than 1. So this is your domain. This is your range. Now let's plot the graph. Now this was our original function. We had rewritten it like this. Now even without plotting the graph, can you tell me how your graph will look like for all the values greater than 2? I have taken the middle value, the place where your graph breaks, which is 2, right? I have taken 2 here. 2 values less than 2 and then 2 values greater than 2, right? So for all the values greater than 2, how will your graph look like? It will be a beautiful straight line because it is a linear equation, a polynomial of degree 1. If it is a polynomial of degree 2, you will get a parabola. But then here it is of degree 1, so you will get one line. But then for all the numbers less than 2, you will get another line. 2 different lines. And where will they meet? Their meeting point will be at this point. The x will be 2 and its corresponding y value. Both of this should coincide. If you put 2 here and if you put 2 here, you should get the same answer. And both of these lines are going to coincide here at 2, 1. Now I have marked the points as A, B, C, D, E. For all the numbers greater than 2, the function that you are looking at, the graph you are looking at is this. So you get such a line. For all numbers less than 3, the function you want is this. You substitute the values and what do you see? 2 lines. And where do they intersect? At the point where there is a break, you see them intersecting. So what does that mean? Look at this. Your values stop at 1. Whatever you do, your graph cannot go above 1. It can go below. It can be like -2, -3. It can go all the way here because it is a straight line. So up till minus infinity, it can take any value. But then if you look at the graph, it stops at 1. It cannot go above that. So what does that mean? Your domain can be any real number. It is the whole of the set of real numbers, but your range, your x value, your domain is your x value, right? So your x value can be the whole of the real numbers, but then your range, or in other words, your y values has to stop here. It is not going to go above that. So that is the answer that we were looking for. Assalamu alaikum.